I'm presenting this poster on behalf of Professor Whittington from Department of Earth and Planetary Science, University of Texas at San Antonio, with title to reduce energy requirement for lunar bricks sort the regolith to increase amorphous content. We set out to determine the range of energy consumption required for production of bricks from lunar regolith using calorimetry on JSC1 as a Mars simulant and a Stillwater anorthosite considering a highland simulant. We studied both powder and remelted glasses for each one. The graph on the left side shows apparent heat capacity versus temperature for JSC1 when it measured as a powder. The heat capacity slowly increases until the glass transition at about 650 degrees. This is followed by exothermic peak at 845 degrees and enthalpy of crystallization of about minus 52 joule per gram. The melting peak beginning at 1020 degrees and reaching a maximum at 1145 degrees centigrade. As a powder, enthalpy required to go from 50 to complete melting are 1775 joule per gram for JSC1 and about 1900 joule per gram for a 50-50 mixture by weight of JSC1 and anorthosite. On the right side, the graphs represent remelted glass for JSC1, Stillwater anorthosite, and 50-50 mixture of JSC1 and anorthosite. In this case, the total enthalpies required to achieve melting are systematically lower for glacier starting materials. For example, 1564 joule per gram for remelted JSC1 and 1670 joule per gram for a mixture for a 50-50 mixture. In addition, sintering can produce crystalline samples without needing to heat much above 1000 degrees, and the release of latent heat of crystallization makes this a very energetically efficient approach, with total enthalpy as low as about 800 instead of 1670 degrees. Therefore, bricks could be produced at lower energy cost by sintering starting materials with a glassy component sourced from volcanic or impact melt deposit at about 1000 degrees. Full results are presented in published paper, Whittington and Parsapoor 2022 in NeoSpace. This research supported by NASA, STTR to Astroport Space Technology and UTSA. Thank you.